Thanks for taking the time to come out and hear me talk a little bit about DynamoDB today. Today I'm going to talk a little bit about the kind of adaptive capacity features and functionality of the platform. And it's really actually a really good timing for me personally to be doing this particular talk because I just came out of the war room from Black Friday and Cyber Monday where I watched this platform perform in every way and deliver on every single feature that I'm going to talk to you about today. So it was really, really cool to see the validation in real time of a system that can scale so dynamically like Dynamo. So today we're going to talk a little bit about, oh, got that the wrong way. We're going to talk about the traditional approaches to database scaling, the way things used to work. And then we're going to get into how NoSQL databases actually scale when compared to relational databases, and why it's really interesting for us to actually look at this new technology, because we are now starting to develop applications that are exceeding the capacity of relational systems. Now we're developing new technologies to extend the life of the relational database, but the reality is we're soon going to overwhelm the processing capacity of the single instance relational database. So we're going to need to look at next generation solutions like NoSQL, so understanding how they scale is actually pretty important. We'll talk a little bit about that. And then we're going to get into the evolution of DynamoDB and how it actually provides the adaptive capacity and this dynamic platform that is so well suited to today's kind of application environment where we want to align the infrastructure behind the demand for an application, right? We don't want to have to provision this fixed infrastructure at peak capacity. We want to have systems that can scale to meet that demand and then go away, right, for some period of time when that demand is no longer there. And Dynamo provides that ability, and we'll talk about how that actually happens. So the first thing to understand with databases is that capacity planning is hard, right? How much do I need and when? And typically, the typical approach is to kind of do this in layers, right? As the demand starts to increase for my applications and services, I'm going to get a bigger box. I'm going to increase more capacity, provision more instances of my database. And what you end up with inevitably is a curve that looks something like this. And we've talked about this. This is kind of AWS and Amazon have talked about this particular aspect of provisioning infrastructure, right? If you're under provisioned or if you're over provisioned, you're paying too much. If you're under provisioned, your customers aren't happy and you're missing opportunities. So the key is to try and maintain some happy medium between the amount of infrastructure I have deployed behind my applications and the amount of capacity that's available for users to actually consume my services. And it's a fine balance. It's hard to maintain. And really, when you scale the relational database, when you start out, and in my career, I've scaled many relational databases, I'm sure many of us have. You start out with a small little instance that supports an application or service, and over time, the demand for that service starts to increase, and so you get a bigger box. And this is how you have to actually scale the relational database. And sooner or later, that demand exceeds the capacity of that box, and now I have to get a bigger box. And I have worked with customers over the years that have gone through single instance servers to Oracle rack deployments to large scale instances that cost $500,000 to deploy. And they go to the MS SQL teams or Oracle teams and they say, how do I'm running out of capacity, my latencies are increasing on my queries, and the answer is get a bigger box, right? And that answer doesn't work at some point, right? The scale of the application is too big, I can't get a bigger box, so what do people do? And I've done this before as well, you partition, right? We start to partition the database, maybe by time, or by sector, or by category, right? These users go to this instance, those users go to that instance. And there's all kinds of technologies out there that do this for you, right? In Postgres, in MySQL, even in the commercial RDMS platforms, they have technologies to allow you to partition and spread your queries across multiple instances of the database. But again, you're still dealing with the same problem, right? They're just silos. It's collections of silos, and eventually you're going to overrun the capacity. Now, when you look at the next generation database technologies that are coming out, you look at this new thing, NoSQL. It's kind of the idea that we're going to run this partitioned relational store, and we're going to overlay some sort of Paxos algorithm or something that's going to control consistency across these instances and distributed locking. And what you're really starting to look at is another layer of overhead, okay? And the reality is the relational database was designed to minimize the footprint of data on disk. It's agnostic to every access pattern, right? Which means it's optimized for none. There's a lot of CPU overhead involved in building the views that the application layer actually consumes. Now, if I could store the data in that form that the application actually uses it, then I can dumb down the queries to simple selects and I can scale better. And the idea of new SQL is great. It's going to give us more scale for relational databases, but again, it's going to come at a cost, an excessive cost. And NoSQL is a better solution. So NoSQL leverages denormalization, right? And shards within the applications or across a key space to provide horizontal scale that delivers nearly unbounded throughput and storage, and we have applications that prove it, both internally and externally. Our customers have deployed massive applications on DynamoDB. 70, 80 terabyte tables exist on DynamoDB. Internal services, we have over 12,000 services at AWS. Many of those services use DynamoDB at great scale. It is really an amazing platform, and NoSQL technology in general is an amazing technology for delivering that type of scaled performance. So how is it all different? And what it comes down to, for those of you who are familiar with the CAP theorem, right? It's often called Brewer's theorem, but the concept here is that we have three kind of points of the triangle. If you're familiar with product management, you know the iron triangle. You get it good, you get it fast, or you get it cheap, right? Well, data has its own iron triangle, and it's called CAP. It's about consistency, availability, and partition tolerance, okay? So when we first talk about consistency, this is about that all clients will always have the same view of the data in the database, right? If I'm connected to the database instance and I read the data, another client reading that same data at the same time will always read the same data. That means the database is consistent, okay? It's available if all clients that are connected to the database can always read and write, all right? That means that the database is available. And it's partition tolerant if the system functions well when network partitions are inserted within the storage layer, okay? So there's three aspects here, and you get two. Relational databases have traditionally picked, and only have always picked, consistency and availability, right? When they're online, all clients can read and write, and all clients will always view the same data, and they do it by maintaining that data in a single instance, a big giant box, all right? When we introduce partition tolerance, you have two choices. You can be consistent and partition tolerant, which means that my users will always be able to have the same view of data, but they might not always be able to read and write when there's a partition inside the data layer, right? I might have to restrict writes and let people only read. They might not always be able to have access to the data. Or I can be available in partition tolerant, in which case I say everybody can write everywhere, but I might not always be able to read the same amount of data, or read the same data. Different clients read different data depending on which head node I'm talking to. Different NoSQL databases choose different technologies or different approaches to solving the problem. And some NoSQL databases like DynamoDB or Cassandra, MongoDB actually give you the ability to kind of play both sides, right? You can enable secondary reads in DynamoDB. You can enable secondary reads in MongoDB. This gives you kind of an ability, what you could almost say the AP approach, right? CP is I'm always talking to the primary. My reads and writes are always going through the primary node in a replicated data store, right? Now I'm consistent, okay? So this is the game we play to try and determine how we're going to be able to scale the database, right? Do I scale within a single instance, or do I scale across multiple partitions? And then that'll tell me where I play, and how I scale across multiple partitions is going to tell me which type of flavor I am. Am I CP or am I AP? Okay, so in a relational store, what we're going to use is a normalized data structure. We're going to take, in this particular example, I got a product catalog. It has an example of all the common relationships that I typically see in a relational database. One-to-many, one-to-one, many-to-many relationships. You can see how many queries, you can imagine how many queries it takes to produce a list of my database, or of my products in my catalog, right? Select star from, inner join through a mapping table to get the many-to-manys. And just think about how much work that CPU is doing to assemble the view that the application needs to consume to provide that list of all my products, and how many independent queries it actually has to run. At least 3, right? I have to get all my books, I have to get all my albums, and I have to get all my videos. And that's going to occur in 3 separate queries. So if I use a denormalized data store as a different approach, I'm going to try and flatten that hierarchy. I'm going to try and push all that data into a set of documents or a set of items or collections of items that I would put on the table. And now, to get all of my products, I say select star from where X equals. Hell, I could say select star from products, and I get every product. I want all my books, I say select star from where the type equals book, right? It's a much simpler query. The system does not have to work so hard to produce the view that the application is consuming. Therefore, I'm using a lot less CPU, which is important because the CPU is the most expensive resource in the data center today, right? 30, 40 years ago, not so much. 30, 40 years ago, the most expensive resource in the data center was actually the disk. So that's why the relational database was actually invented. If you talk to people who are actually dealing with data and generating, reports and analytics and things like this back in the 70s, right, they all used comma-separated value, flat files, grep, awk, sed. This is what people used to process the data. The relational database came along to minimize the amount of storage that those processes were consuming, right? 40 years later, it's the flip side. The CPU is the most expensive resource. The storage is the cheapest thing in the data center. So why would I use a technology that is optimizing the cheapest resource in the data center and making me pay for the most expensive thing, right? I actually want to go the other way. I want queries that are simple queries. I don't want queries that are complex, okay? So this is where NoSQL really starts to excel. So when you scale a NoSQL database, it's about adding capacity incrementally. It's not about having to get a bigger box, right? You make a bigger array of instances, right? So you start off with one instance, you add some more capacity by adding another instance. You add additional capacity by adding more instances, but as I do this, right, I am not throwing away the old boxes. I'm expanding the new, and by adding additional boxes. Now, as you do this underneath the covers, what's going on is there's a replication process, right? I add new instances into this array. What I'm doing is I'm adding a new shard to my cluster, and that shard now is going to give me additional capacity, but it's only going to give me additional capacity when the items are distributed evenly across from the other shards. So there's this background process that's happening that's replicating the data, okay? This is important when you get into actually managing this yourself, because if you want to deploy NoSQL databases, you need to understand what is the background consumption that you're going to occur in managing the system, okay? I have customers that have deployed, MongoDB clusters that literally can't add capacity for weeks because it takes that long to replicate from all of the shards, right? We have similar issues in DynamoDB. We have to deal with that replication, but as a managed service, it's something we do for you. It's not something you have to worry about. You don't have to provision extra capacity because I'm going to be adding a shard in 6 months, right? We kind of do that. We take care of all of that. Anyway, so when do I use NoSQL over SQL? What it comes down to is if I understand the access patterns of the application, then I'm going to be way better off using a denormalized data store that stores the data in the way the application actually uses it. So OLTP applications are great because they always use the same data. They'll use the data the same way all the time. So when I'm building an application and I know it's an OLTP app, and every time somebody hits the order button, they're going to commit those items, they're going to commit that purchase, they're going to do whatever, right? Then a NoSQL database is great. Now, if it's a ad hoc queries that I'm looking for, BI analytics, OLAP workloads, the type of things that I don't know how people are going to use this data, then maybe an SQL database might be a better store for you. And again, a couple options here. You can even look at NoSQL to back the OLAP workloads, but it's kind of like the data lake. We push this stuff out there. We run an EMR cluster or some MapReduce engine on top of this thing. Maybe we load some Hive or Spark or Presto library on top of that. And we can run SQL queries, and we're storing the data in a NoSQL database, but those are kind of long-running queries. If I need real-time ad hoc queries, SQL is a good solution for you, but it's not going to scale as well as something like a NoSQL database, certainly. All right, so Amazon DynamoDB, for those of you who are not familiar with it, it's a managed NoSQL database service. This is one of the biggest value points of the service. Anyone who's tried to manage NoSQL at scale knows how difficult it is to keep these things up and running, right? You've got a whole bunch of servers, you've got a bunch of OS patching, you've got a bunch of database patching, all kinds of stuff you have to worry about. And then when hardware starts failing, I have to re-replicate. I have to administrate and operate this IT infrastructure that is not necessarily core to my business. And at scale, this becomes very complex. I mean, it's one thing when I'm running a single replica set It's another thing entirely when I'm running 15 shards, right? So, when you think about the ability to actually offload all the management of all of that infrastructure, because NoSQL databases, they're great. They scale fantastically, but there's a lot of work that goes into it. And it's not something that's easy. So if you don't actually need to scale, then I would actually say let's use a relational store. You get a lot more flexibility out of it. A lot of people talk about NoSQL as if it's a very flexible data store, and it is. But it also requires a lot of rigidity, right, in the data structure. So in order to be effective, you can't really run ad hoc queries. I can only run these access patterns that I actually understand and know. So if I need to run patterns that are more ad hoc, I want to run a relational store. Anyway, so DynamoDB is fast and consistent, and it scales designed to deliver high performance for any workload. Scales independently for reads and writes, and you provision capacity independently for reads and writes. Fully integrated access control and fine-grained, so at the item level, at the table level, and at the attribute level. I can create users and assign permissions to those users that would be able to read only parts of the items, right? So I could have, like, say, an order entry application with an HR overlay, and only my HR users would see the extended metadata that's associated with the HR functions, right? And order entry applications would see only OE-style attributes. So one thing about NoSQL and the way that we actually distribute data in NoSQL, and all NoSQL databases use this same approach, is there's some sort of partition key, shard key, some attribute that's a mandatory attribute that must be provided in the item. It's the only mandatory attribute. It uniquely identifies the item. And what we're going to do is we're going to hash that attribute value and create this unordered hash index and lay these items out across this arbitrary key space. Now, once we've done this, as you add capacity or you increase the storage and add more items into the table, we're going to start splitting that thing up across physical boxes. Okay, so this is how DynamoDB scales. This is how MongoDB scales. This is how Cassandra scales. This is how NoSQL in general scales. All NoSQL technology shares this same approach to scaling. You create an arbitrary key space, you lay the items out across that key space, and you chop it up and put it out onto different physical boxes to be able to scale up. Partitions are three-way replicated in DynamoDB. In most NoSQL databases, there's some sort of replication to ensure durability of the data. In DynamoDB, they're three-way replicated across 3 AZs. Every region in AWS has at least 3 AZs, whether you see them or not. And it's because DynamoDB is a tier 0 service. No other service deploys without it. So we can't, no region stands up without it. So we can't, and DynamoDB requires three-way replication. So even if you're only seeing 1 AZ, like in some of our new regions, like in China for a while, there was only 1 AZ. There's really 3, but that's for the backplane infrastructure that we run things like DynamoDB in. And that replication is automatic. It's nothing you need to enable. When you define a table, it's just going to get replicated across those 3 AZs. Now, behind the scenes, and this is where things start to get really interesting and start to get really different when you look at DynamoDB. Behind the scenes, we run basically a massively multi-tenant infrastructure. All right? We have storage nodes and request routers and control plane infrastructure, and it's all basically serving up requests for many, many, many customers. Right? So when you deploy DynamoDB tables, we don't roll out dedicated infrastructure for you. We actually claim capacity on existing infrastructure. And what we're doing is we're taking your table and your data and we're chopping it up into all these partitions and we're spreading it out all over this infrastructure and we're sharing that infrastructure with other people's tables, right? Might be yours, might be other customers. These things are logically isolated. Nobody can touch anybody else's tables, right? Your data is completely and totally isolated from other users. The interesting thing here is that we don't take full servers and chunk them up and put them into your table space, right? That would be expensive. And many of our competitors, this is what they do. I mean, the minimum bar to enter on some of our competitors' products is very high, and it's because really they're taking dedicated servers and they're throwing them into that, out there for you. You can think of these things as EC2 instances. In DynamoDB, our partitions are really small, okay? They're small for a lot of reasons. Bottom line is every single partition you have on your table is going to give you 1,000 WCUs or 3,000 RCUs. These are read and write capacity units, or some mix of those two, and up to 10 gigabytes of storage. Now, why do we do this? Because we want to scale, and we want to scale fast. And that means that I can't spend my time replicating data out of these partitions. If I need to split these partitions, I don't want to have to copy a petabyte of data, right? I copy 5 gigabytes of data and I've split the partition. So it happens really fast. And I've seen this in real time. It's an amazing thing to watch a table go from 2 to 4 to 8 partitions in minutes and be able to scale from 2,000 WCU peak burst to 8,000, 400% capacity increase in minutes. Who does that? What database can do that? There's only one in the world, right? It's DynamoDB. All right, so when you scale DynamoDB, it looks like this. It doesn't look like get a bigger box, and when your load goes away, wow, I'm stuck with this big box, right? When DynamoDB, when the load goes away, you can dial it down. And when the load comes in, you can dial it up. And it happens really fast, okay? I mean, literally, I sat there on Cyber Monday in the war room. I watched these tables going, ballistic, and I was watching the peak rush. We monitored over 2,000 tables. I run the DynamoDB Black Belt team. We monitored over 2,000 DynamoDB tables for what we call the Amazon CDO. That's our commercial, digital, and other development teams, right, through Black Friday and Cyber Monday. And I'm watching the tables go into a hot state, throttling, the provisioned capacity throttling, peak throughput throttling, burst throttling, and I'm looking at the teams. I'm saying increase the capacity on these tables, split these tables. We need to increase your burst capacity, and I'm watching all of this happen in real time. Dozens of instances, right? Things that would take businesses down. And we're able to withstand this because we have this dynamic backplane that can increase capacity on the fly in such an amazing way. All right, so what you end up with this system now is something that's highly exact. You do not have to operate in whole server increments anymore. You get capacity fast, right? It's quick. In minutes, you're going to have the additional capacity you need. Right? You're going to have some account level limits. Those are soft limits. There's table level limits. Again, soft limits. If you talk to our support teams and let us know how much capacity you need, we'll dial you right up, right? And you can claim any amount of capacity that you need. We just need to know, right? You're going to deploy with a certain amount. Anything within that is available to you. Above that, just let us know. Again, fully elastic, up and down whenever you need this thing to go. You just set it up, you can dial it up and dial it down both manually and automatically. We have some great technology for you there we'll talk about in a few minutes. But what this allows you to do is maximize your application's availability, minimize your cost, right? No downtime. I mean, we've got great examples of applications. I've got an application, it's a survey form processing application we wrote for Amazon's, for AWS professional services in the SA team. When you interact with us, you're going to get an email. At the bottom of that email will be a little link. It says, what did you think of this interaction? When you click that link, it pulls down a web form out of an S3 bucket. If you post that form, it hits API Gateway. API Gateway calls Lambda. Lambda processes the form and shoves the results into DynamoDB, notifies the manager the survey came in. This app runs, we host it's 3 cents a month, right? I mean, how many surveys do we process? Maybe a couple hundred a month. But the reality is if 1 million users showed up tomorrow, all I need to do is dial up the capacity on that DynamoDB table and I can support them. So what other kind of technology can give you that kind of flexibility, right? When you combine serverless with Dynamo, it is amazing what the possibilities are. So anyways. Results, hundreds of thousands of customers, millions of requests per second. I think on Prime Day we peaked around 34.5 million requests per second across regions. We had hundreds of billions of items we store on our tables, petabytes of storage. Literally, there's nothing that operates at the scale of DynamoDB. It's an incredible system when you really get to look at it. There's nothing, nobody in the world has deployed anything like this. So, let's get into adaptive capacity. We want adaptive capacity because when you get capacity planning right, nobody cares. But when it's wrong, boy, everybody's on the phone. So we don't want that. We want things to be able to scale up and scale down. So let's talk about how that works with DynamoDB. When you first deploy a table, in this particular example, we're going to deploy a table that has 500 WCUs, 1,500 RCUs. That's going to give us a single partition. Okay, that single partition sitting there, it's got those partition level limits. Now those partition level limits are actually soft limits. All right, every table in DynamoDB gets 5 minutes of burst capacity, what we call as unused capacity and it's available for burst. So let's say this table sat there for 5 minutes and it was unused. It would end up with a 450,000 RCUs and 150,000 WCUs sitting in its burst bucket available for use. Now, since it has only one partition, a single partition can give me up to 1,000 WCUs or 3,000 RCUs. So the burst capacity of this table is up to 5 minutes of sustained traffic at 1,000 WCUs and 3,000 RCUs, because it's a single partition. So you look at that, take that 5 minutes of unused capacity, here's my burst bucket, add the capacity that I have provisioned. How long does it take me to drain my burst bucket based on how many partitions I have on my table? In this particular case, 5 minutes, right? So let's say we go along, we start to add more data to the table. We get up over 10 gigabytes, right? 10 gigabytes partition splits. We start to see some interesting things happen. Now we have 2 partitions. So we haven't increased our throughput at all. We have the same amount of throughput. So that throughput is actually evenly divided across the 2 partitions, and it's put there. So now these partitions, each one has a soft limit at 250 WCUs and 750 RCUs. But what's interesting here is I've actually doubled my burst capacity, right? My burst throughput capacity. Since I now have 2 partitions, and then each one of those can give me up to 1,000 WCUs or 3,000 RCUs, the burst throughput of the table is increased from 1,000 to 2,000 WCUs, and from 3,000 to 6,000 RCUs, right? And now I can get up to 100 seconds instead of 5 minutes because I'm bursting at a higher rate. I'll drain my burst bucket faster. I can get up to 100 seconds of WCU or RCU burst, all right? So pretty straightforward. The more partitions you have, the higher the burst throughput capacity of the table, right? I always have 5 minutes of unused capacity. So we go on, we split, add more data. Again, we start to dilute. We split again, we add more data. We start to dilute, right? And so what's happening is you can see these partition level soft limits, they're kind of falling, right? And so you say, well, gee, what happens if I get over, if I don't have a fully evenly distributed load, right? I mean, now I'm split out to 4 partitions, that's great. I have a really, really hot table that can deliver a lot of capacity on burst, but, you know, I mean, what happens if I actually need one to deliver more than 125 WCU and I'm out of burst, right? So in this particular case, what ends up happening, let's just talk about a real scenario. So in this particular application, let's say you're hired by the Statistics Canada Bureau to build a census application. And you decide that you're going to use the following schema for that application. You're going to partition on the province. You're going to sort on the user's ID. So that's great. Seems pretty even. No problem. Lots of provinces in Canada. Lots of people live in Canada. What you didn't really realize when you made that choice is that 50% of people in Canada actually live below the latitude of Seattle, okay? So it's kind of a very uneven distribution of population, right? We have 1 or 2 provinces in Canada that actually have all the people. Nobody else has any people. So when you start to load the data into the table, let's say we provision this table out there at 100 WCUs, and we start to take our census data, we're soft limited out at 25 per partition, and boy, we're loading data into that Ontario and Quebec partition really, really hot, and it's getting too hot. So what actually starts to happen in DynamoDB? So this is a real table, a real situation. You know, we just took this out of the, from CloudWatch, but what happens is you're going to see that soft limit start to be exceeded. And at that point, there might be a little bit of throttling on the table because we're exceeding the soft limit and we've exceeded the burst bucket, and now we're trying to figure out, does this table actually need some additional throughput? Once we detect that this soft limit is a sustained burst, it's not just a transient condition, we're going to enable what we call adaptive throughput on the table. That then will cause all of those soft limits to be eliminated to a certain extent. The read and write ratios will be increased on those particular table partitions, and they will be able to effectively borrow capacity from their unused partitions. All right, what they're really doing is they're using background capacity that's on the storage node they're deployed on. Right? We don't want to enable this on every table by default because we have to actually orchestrate these workloads somewhat to make sure that we have the capacity available to resolve these burst requests, right? These adaptive throughput requests. But when we see tables that have this condition, we will put them into that adaptive throughput mode, which allows them to borrow their capacity. You can see how that now causes that nice even slope for the demand on the table. So if we look at the per partition throughput while this is happening, you can see very clearly what's happening. So each one of these little lines on that graph is one of the partitions on this table. That red line is the 25 writes per partition. That's the soft limit. We can see that the Ontario partition is starting to flame beyond 25 writes per partition. So we see a sustained throttling situation, and at some point adaptive throughput is enabled, and now all of a sudden that partition can start to borrow from the other partitions. Now, it's not going to give you more than what you have allocated on the table, right? If you're only going to get adaptive throughput if there's capacity left on your table. If you provision 100 WCUs and you're using 100 WCUs, it won't matter what partition is too hot. You're just not going to get any more. But if you have capacity on the table, you're not going to get throttled for sustained periods. You're going to get adaptive throughput enabled, and those partitions are going to be able to now start to borrow from each other. So this is great. I mean, to tell you the truth, this helped a lot of tables on Prime Day. Over 2,800 Amazon tables would have throttled on Prime Day. And we have had tens of thousands of customer tables that have benefited from this, right? This got turned on about 6 months ago. Customers didn't even know it was being turned on. So there are customers that previously would have been throttling based on these partition level limits who have been benefiting from adaptive throughput for months they don't even know because the tables aren't even throttling. Again, this is the evolution of our platform. We saw the way people use the technology, and we're improving the way the technology performs to meet the requirements of our users. All right, so everybody wants a hands-off experience, right? I can't wait for this. I want a fully automated car. I don't want to drive my car anymore. I'm tired of it. But we give you that hands-off experience for DynamoDB, right? I mean, there's a technology we have out there called Autoscaling. Some of you may be familiar with. There was a library around for many years. This is now an integrated part of the platform that you can enable. And it's a really cool solution because it allows you to eliminate that let's provision for peak type of mindset, right? What you do with auto-scaling is you set a high water mark and a low water mark, at which point the system will increase or decrease capacity based on the load. And you can set those thresholds at a low level, at 20%, give them double my load because I'm going to expect the rush. Or hey, I have a soft curve that I know, and so don't increase to 70% consumption. It's all up to you. But you can see the chart on the left here. You've got a table that in the past would be provisioned for peak capacity, and all that area under the line, all that white space, that's just wasted money. Okay? And then when you look at the chart on the right with auto-scaling enabled, now all of a sudden you've got provision throughput that's following the demand. And if you took the area under that red line, all the white space, it's going to be a heck of a lot less than the area on the left. So you're going to save a lot by being able to do this. Now, again, watching this happen. Now, the way I actually advise teams on Prime Day and on Cyber Monday and Black Friday was to use kind of auto-scaling as the insurance policy, right? You set your floor at the highest you expect, at my peak expected level, because heck, we know the traffic's coming. So why do I want to stand on the train tracks and stare down the train and make sure I can jump off fast enough, right? I mean, we want, if I know the train is coming, then let's make sure it's got room, right? So I tell the teams to provision auto-scaling at the high level and use it if you get an unexpected burst or demand, right? And then auto-scaling can kick in and increase additional capacity over the top. Now, we had 3 teams do that, and one team on Prime Day was huge. This was the team that manages the deal box on the front of the web page, right? What are the hot current deals? Well, they got 300% demand. They needed 300% capacity of what they expected. They'd provisioned their auto-scaling out there, and the ability of the system to respond to that was actually just incredible to watch in real time. Within 10 minutes, these guys had requested double the capacity. It wasn't enough. They requested another 50% of the capacity on top of that, and within 20 minutes, that table went from 100,000 RCUs to 300,000 RCUs, and in real time. So you just can't do that with a regular database. Right? If I'm deployed with a MongoDB cluster or a Cassandra cluster, oh my gosh, I'm stuck for the duration, right? That's as much as I'm getting, and there is no more, because even if I added a shard, I'm actually going to be not doing myself any favors, because when you add the shard to a traditional NoSQL database, what happens? The throughput goes down until that shard is replicated, right? I'm actually consuming capacity from the cluster to replicate the data to the new shard. And I have seen customers that are under load if they run too close to the ragged edge and they let the utilization of their cluster get too high, then the replication will fail, right? Because the replication log will roll before the cluster can actually get caught up, and at that point it has to start over again. So I have seen customers that have to go into an API throttling stage or state because they can't let the database get beyond 70 or 80% utilization because the replication lag starts to crush them and they'll never get another shard, right? So literally customers now starting to add shards at 50% total capacity, they just start adding shards because they know in 2 or 3 weeks when it's available they're going to need it, okay? So if that's the game you want to play, that's okay, but I think that what you really want is something that's going to be adaptive, reactive, and meet the needs of your applications in a very elastic way. And there's very few services out there that can do that. DynamoDB does it in a very, very effective way, and many customers rely on it. I mean, big customers, right? I mean, you see the logos on here. Major League Baseball, Advanced Media. These guys do the StatCast, right? If you're familiar, if you're a baseball fan, you ever watch some of those replays, and it shows, here was his acceleration. Here's how fast he was running. Here was the shortest distance to the ball. Here's the path he took and how long it took. All that data is being processed on AWS infrastructure. It's being stored in DynamoDB. And again, a great use case for autoscaling, right? The ability to, when the games are playing, they need it. When the games aren't playing, they don't need it. So why pay for it, right? And that's, they save a lot of customers, saving a lot of money that way. Expedia, Canon, Under Armour, BMW, you name it. I mean, and this is just a sampling of the logos, right? We have thousands and thousands and thousands of customers using DynamoDB in huge ways. Next feature we could talk a little bit about, which is really cool, is TTL. This gives you the ability to kind of scale your capacity down automatically. So as you start to increase or process data against a table in many applications, the data might get stale. Maybe it's event data that after a week or 2 weeks, I really don't care about anymore. I want that data to clear off the table. So maybe when I insert the items on the table, what I'm going to do is add a little attribute called TTL. It's going to have a timestamp in there. When that timestamp is expired, there's a sweeper that comes along. He's going to clear those items off the table for you. So the nice thing about this is it can really reduce your costs, right? I mean, why store all that data on the table if I don't need it? TTL items are going to show up on what we call the DynamoDB stream. Stream is like the running change log of write operations against the table. So when a TTL delete occurs, that item is going to actually show up on the DynamoDB stream, and it can be processed by a Lambda function. So it'll read the item. It's going to say, hey, this was a system delete. That indicates it was a TTL operation to clean that thing off the table. And you can decide, I want to archive this. Maybe I want to put it on a cold table or whatever you want to do with that data. But basically, get it off the table because you don't want to store it unless you're actually going to use it. And customers have really benefited from this, right? We had Tune was one customer, purged 85 terabytes of data just by enabling TTL. And they ran a table scan, added that TTL attribute to all of their items when the feature, and they actually did that, I think, well before the feature was delivered. And then when the feature was actually enabled in the regions where they had those tables, it just picked up that TTL attribute and swept off those items. 85 terabytes saved $200,000 a year. CloudWatch, our internal service for monitoring all of our AWS services, reduced overall provision throughput by 75%. And the reason why was because they were actually using some inefficient queries. They were querying using filter conditions. Filter conditions cause you to read all of the items in a given partition and then filter the items only that match. Well, when their partitions got big with a bunch of stale data, they were reading a whole bunch of data they didn't care about, and then they were applying a filter condition to knock them out. And so they kept on increasing capacity, increasing capacity. Finally, they realized what was going on. They enabled TTL, reduced their provision throughput by 75%. Now, they're going to save millions of dollars, right, for Amazon over the next year or two. So, I mean, huge features that allow you to kind of dynamically scale the database both up and down. And the bottom line is, when you get into managing databases, it's not easy. Anyone who's done it knows it's not easy. You've got servers, right? Servers need to be, you've got capacity planning behind that infrastructure. You've got provisioning. You have OS patches. You've got monitoring of that infrastructure. I've talked to customers that have entire IT organizations dedicated to managing their database clusters. They're not in the business of managing database clusters. I mean, in some cases, these guys are in some of the most, non-technical industries. yet they're having to maintain a very high level of technical skills in IT operations to maintain this infrastructure. So don't do it. You've got database software, upgrades, security patches, scaling issues, right? Monitoring, performance tuning, re-replication. You deploy all this infrastructure. When you got 15 shards out there and you got all these servers running, anytime anything fails, it's like, uh-oh, step up a new server, step down that secondary, re-replicate. This is a constant process, right? That replication steals capacity. And this is really one of the things that's important about DynamoDB is you don't need to allocate any of that capacity, right? It's all priced in. You turn on the table, you say, here's how much capacity I want, and you're going to get 100% of that capacity for your app. You're not going to have to burn any of that capacity, take care of background management, not any replication. None of that stuff is your responsibility. That's all our responsibility, and that's what we do. You tell us what you need for your application, and it makes it so nice because capacity planning is reduced to simple math. If you come to my DAT327 session, I go through some design patterns on right sharding, and I talk about how to determine how many partitions I need to be able to meet the query load that I'm putting against these partition keys, and it comes down to it's very simple math, right? How many requests per second? How big are my items, right? How many am I putting in a single partition? Okay, I mean it's very simple math versus this. This is complex, and you're going to do all this yourself, and you're going to do it with zero downtime, right? No, you're not. Okay, most organizations never achieve this. We have, and it's because we operate at a scale that's well beyond what most people would ever even dream of operating. If you look at Amazon's DynamoDB processing plane, there's not an enterprise in this world that matches what we have deployed, and it serves what we serve. Petabytes of data, millions of requests per second. It's a fully managed, fully adaptive database service. And now with the features that we've just released, I mean, this thing is really ready for prime time. The scalability, the adaptive nature, the elasticity of the system, you're just not, it's not, I've looked at everything. I've worked at other NoSQL technology providers. There's nothing in the world that matches the performance and the capabilities of this system, and I would recommend that you try it. It's a fantastic system. All right, I know we're a little ahead of time here, but I don't think I've got much more content for you. Thank you for taking the time out of your day to come listen to me. If you have any questions, step up to the microphone and fire away.
What advice do you have for folks who end up in a situation where scaling up causes partition splits, and then they want to scale back down to where they were at the table level, but they have less capacity per partition at that point?
Yeah, so this is exactly why we've introduced adaptive throughput, right? So those partition level limits now, it's what I've referred to in the presentation as soft limits. They're no longer the hard limits they used to be. These are, so now what you can do is you can scale I wouldn't say scale out and split without even thinking about it, right? We don't want those partition level limits to drop down to like 1 RCU, right? But we don't need to be so worried about those partition level limits dropping, because with adaptive throughput, if the workload starts to flame above the limit, the soft limit, you're going to borrow from your other partition. So as long as you're below your table capacity, you should be okay.
And that kicks in after about 10 minutes?
It takes about 5 minutes for it to be enabled. Yeah,
okay.
Yeah. We need to see one CloudWatch cycle, and then it'll go ahead and kick it on. And then what starts happening is it starts adjusting the ratio, right? It'll start seeing that, okay, you need maybe you need 1.1 to 1 ratio. Now I need 1.2, and so on and so forth. It'll increase all the way to 3,000 to 1, but that would mean that you'd have a really, really diluted partition. So we want to avoid that situation. So, cool.
Just curious, for the...
I'm sorry?
Do you drop the partition? Let's say you scale to whatever.
Oh no, we don't ever reduce the number of partitions. But so that was the question. The question was, when we scale back down, do we reduce the number of partitions? No, we keep the number of partitions the same. The soft limits get reduced, and then adaptive throughput's going to kick in faster. That's what ends up happening. So, okay.
Just curious, for the prime day for the prime data, millions requests per second, how many equivalent hardware are you doing needed to support that kind of?
I'm sorry, I'm not understanding the question.
So the prime data, for the prime data, that kind of a big, huge amount of throughput, how much hardware we're talking about to support that kind of throughput?
Oh, how much hardware?
Yeah, just curious.
I mean, to the customer, it's an abstract concept, right? You just say, I need X RCU, X
But for
WCU.
your own operation to support that kind of throughput.
Yeah, I mean, I couldn't tell you. I have no idea how much hardware it takes to support a million RCUs or a million WCUs. That would probably be a better question for the backplane engineers. But like I said, for the customer's perspective, that's just not something that you need to be aware of, right? Because you're just getting a bunch of 10 gigabyte partitions that can do 1K RCU or 1K WCU and 3K RCU. So if you need a million, divide by, right, 1K, and that's how many write partitions you're going to get. So, cool.
Hi.
I think we got some questions over there. Yep.
Yeah. So backend engineer at Tinder, our access pattern is very, some people swipe a lot more than others. So we get a lot of hot sharding, right? My question is, how quickly does adaptive capacity kick in when you're getting throttled on a shard?
Okay, so what's going to end up happening with adaptive throughput is the first time it's enabled, it's never going to get turned off, right? Unless your workflow access pattern completely changes. So if you're seeing hot keys, there's a couple things that could be happening. We probably want to talk actually. It could be that you're seeing a peak burst throttling, which would mean you're asking more than 1,000 WCUs or 3,000 RCUs per second per partition. If that's happening, then all bets are off. Adaptive throughput's not going to help you. And maybe what we need to do is actually split your table and give you more partitions. Like I talked about how you get more throughput. Right. So I'd want to know, are you burst throttling? Then I would want to look at, if you're not burst throttling, then are you hotkeying, right? I would say with your use case, it'd be hard to see how you'd be hotkeying, but I want to understand your access patterns a little better. Bottom line is, with adaptive throughput, 5 minutes to turn it on, it's going to start load leveling you. It'll never turn off. It'll go all the way down to 1, which is effectively turned off, but it's always going to be watching your table at that point, and so it would be able to kick on really fast.
When you say split the table, do you mean actually two separate table definitions?
No, I mean, when I say split the table, I mean double the number of partitions.
Oh, gotcha.
Yes,
okay.
to give you more burst throughput.
Right. What we're currently doing is we just increase the provision throughput by like 20 or 30% higher than our consumed capacity.
Okay.
It ends up costing us more money though.
Yeah, so now, and are you running, generally speaking, are you running at 70-80% consumed capacity?
Yeah, pretty much.
Okay, so now that's a pretty good chunk, and I always tell people at that level, you're going to start seeing random and spurious throttling, right? Because it's across the key space, and it could be that this slight imbalance of requests is starting to hit this partition a little bit more than this partition. So my bet would be your peak throttling. And what we'd want to do is we do want to get the capacity bump, because at 70-80%, it's just at that level where you're going to see spurious throttling. Now, you could instrument the application to do a back-off retry, right?
Yeah, we do that.
Okay, and that should resolve. I would imagine that should be resolving most of your issues.
Our
right?
error rate is really low. It's more the cost.
Okay, yeah, no, I get you. So you know what you probably want to do, you guys have enterprise support. I'd say let's get a consultation set up with the specialist SA team. I think we've got an EBC with your team, actually.
We do.
Yeah. And so if you maybe talk to, I think Sean Shriver might be the one who's going to be in that, so go ahead and ask this question of him. And if you need to, I'm happy to engage as well. I run the black belt team, so we can sit down and talk with your team about how you're using it and see maybe there's a better access pattern.
Okay, sounds good.
All right, thanks a lot.
My name is Sai. I have a question. So if the latency for reads is going to remain constant, I'm just thinking, how does it compare with, say, something like elastic cache? Can we remove elastic cache and rely completely on DynamoDB because I get durability for free?
Sure. So first off, I would say now with the introduction of DAX, which is DynamoDB Accelerator, it's a fully integrated front-end distributed cache for DynamoDB. I would stay away from Elastic Cache because that's kind of side cache implementation that you have to manage, right? So DynamoDB DAX, if it's available in the regions that you're deployed in, I believe it's available, should be available in all regions now. You might want to verify that. I would just go with that as your caching front end. That's going to give you sub 1 millisecond latency, and then you won't have to worry about cache population, right? Because all your reads and writes are going to go through that cache instance. With Elastic Cache, the cache sits on the side, and what you do is you hit the cache. If it's not there, I go read the table, and then I have to stick it in the cache, right? With DAX, I read DAX. If it's not there, DAX goes and gets it. So it's a much better solution than Elastic Cache.
Even with the consistent reads?
Okay, now if you're looking for full consistency, then there's a couple of scenarios, right? If you got a single DAX head node and all reads and writes are going through the DAX head node, then you're guaranteed consistency on your item rights. Now, query result sets are cached independently, so you want to set the TTL for your query results very short. If you need full read consistency and you have and you have too much data sitting in a single DAX instance and you have to run distributed, then what's your latency requirement? Do you need sub 1 millisecond or is low single digit millisecond okay?
A single digit millisecond.
Okay, then you don't even need cache. I just go hit the table because by default, DynamoDB operates in eventual consistent reads, but you can turn on consistent reads. Once you turn that on, it's going to double your read cost, but it's going to give you a consistent read, and it's going to give you a low single-digit millisecond response time on average. So I would go with that.
Thank you.
Okay, so you mentioned that DynamoDB is a database that can be both CP and AP. So can you give some more information on
Sure. So it was kind of a similar discussion, right? So by default, a DynamoDB is, well, it's architected to be a CP system, right? So it means that all writes go to the primary. They're going to get replicated to secondary before they are going to be acknowledged to the client. And you know, in the default read condition would be to read from secondary. Okay, that's what gives it kind of an AP flavor, but it's not really AP. It's still CP because all writes, it's a single master, right? So all writes go to the single primary within the region. Now, a technology like Cassandra, okay, that's true AP because it's headless master-master, right? There's no single master node that all the clients must talk to. I can write to any node in a Cassandra ring. Right now, there's different conditions around that right. I might give a quorum right, whatnot, but bottom line is any node in a Cassandra cluster can take the write. So that's what makes it AP, right? Because if there's a partition between the nodes, then I have a client talking to node A, a client talking to node B, and there's a partition. Well, guess what? They're both going to be able to read and write. So it's available, and it's partition tolerant. But it's not going to be consistent, right? Because those two clients, once they start writing the data, they ain't reading the same data no more, right? So that's what makes it AP versus CP. Now, Dynamo can never be truly AP, and neither could Mongo, right? Now, when you get global tables is like global master-master. Now, all of a sudden, Dynamo can start talking about being an AP system because I can have a write to region A and a write to region B that could occur on two different tables, and then they're going to have to resolve at some point.
So to summarize, basically, you always write to the master shards, and
within the region, the writes are always going to the primary of the replica.
And you read from every shard.
You can read from any one. Now, you can when you enable EC reads, you read from secondaries only. There's two secondaries. When you enable consistent reads, you read only from the primary. There's one primary. That's why EC reads are half the cost because I got twice the read capacity.
Okay, thanks.
Cool.
Do you always split partitions on equal halves in terms of provision and throughput?
Do we always
split partitions?
Do we always split them equally? Well, there's two ways partitions split on DynamoDB. One is by capacity and one is by size. When a partition splits by size, it's going to be the one that grew too big. All right, so this one's bigger than 10 gigabytes, and there's no hard line at 10 gig. There's a hard line at 20. So on the system, on the backplane, we're going to decide somewhere between 10 and 20 gigabytes, this guy's got to split. When it gets to 20, it's going to split, okay? So that's one way that it splits. The other way it splits is by capacity. So when you dial up the capacity and you provision the table, there's a little bit of math we go through to figure out how many partitions you're going to get initially. When you dial the capacity beyond that point, we don't really know how to allocate it, so what we do is we just double the number of partitions and divide the capacity that you've allocated across those partitions and call that the new soft limit. So if I have 10 partitions on my table, let's say I deploy the table with 10,000 WCUs, it's got 10 partitions, and I provision to 11,000, it's going to end up splitting to 20 partitions and dividing 11,000 WCUs across those 20 partitions. Okay, so that's why that partition level throughput used to be really deadly, right? Because you really needed to know when you created the table what your maximum throughput would ever be, because if you ever dialed it up above that, oh boy, you could have your partition level limits in a heartbeat and not know it, right? But now with adaptive throughput, not so painful. I actually have been recommending people to split their tables for burst throughput capacity quite frequently lately, and it's been awesome because I've been very closely watching all of those tables to make sure that I'm not getting them into a bad state, right? Because it's not something I was normally recommending, and now I am, and it's been great to watch how the system's performed with it. I just see those read-write ratios increase on those tables. Adaptive throughput comes through, and now they've doubled their burst capacity, and it doesn't even matter that they've got a lower soft limit on the table, on the partition level. So that's kind of where you go with that.
All right, just to clarify, like in the past, in the given point of time, all partitions had always the same provisioned throughput?
Not always. So when they split by size, they're going to, well, again, with adaptive throughput, your statement is generally accurate. Absolutely. Because adaptive throughput will compensate for any partition that is lower than the others. But the soft limits may vary, all right, depending on what we call the split generation of the partition. If all the split generations are even or are the same, they're going to have the same partition level throughput. If the split generations are different, meaning these split by size, then these split by capacity. You see what I'm saying? The ones that split by size, well, they're going to take the limit that came from the parent and they're going to divide it between the two. Okay. Right, so those might have a little bit lower limit than the ones above on the generation previous, right? So it's not quite as clean as there's no real clean formula to determine it. Again, the leveling factor here in all of this is adaptive throughput, right? Now that that's in play, all this other stuff, it's just soft limits. It's more interesting to us than you, right? Because we just need to know where the soft limits are so we can turn on the adaptive throughput. For you guys, it's like, okay, sooner or later it's going to get turned on if I need it, and I don't have to do anything to make it happen, right? So this whole worrying about partition level limits thing is just, it's becoming a non-issue, which is making my life a lot easier.
It gets enabled after 5 minutes.
Yeah,
so
after 5 minutes.
You have to do something during these 5 minutes.
Yeah, during the first 5 minutes, you'll see throttling, right? So I would enable that. I would recommend in your application layer, and I always do, that you implement a throttle retry algorithm, right? So when you see that right throttling on the table, that you're gonna wait 100 milliseconds, you could try again. You're gonna wait 500 milliseconds, you could try again. If you're still erroring out, maybe throw it in a queue and try again if your workflow allows, right? Or throw the application layer error after you've throttled 2 or 3 times. Don't do it right away, right? This way, if you can queue up those requests, that throttling will eventually go away.
Thank you very much.
No problem.
All right. Can you talk a little bit about how we should think about the play between auto-scaling and reserve capacity?
Okay, so, well, reserve capacity is really just a pricing discussion, right? It's like how much throughput do you expect to need on your table, then you should buy some reserve capacity. And I would always recommend to people that you don't hesitate to buy reserve capacity. If you have a production app and you're deployed and you know you're deployed, buy reserve capacity. It's just a big savings. It's not like instances, right? When you get reserved instances, you're kind of, and I actually think this is even better now, but because you can upgrade reserved RIs now, but it used to be with the RIs that in EC2 that you're kind of stuck with that instance for the duration of your contract. With reserve capacity, it's capacity, right? So it's not ever going to become obsolete, right? So you can buy half what you need now, another half in 6 months, another half in 6 months or whatever, and it's not going to, it's not a problem. You're never going to.
I mean, so if we have like daily bursting, do you recommend like buying the lower level for reserve capacity and then like, not purchasing anything for?
Again, it's an accounting decision for you, right? I mean, if you're comfortable buying a 3-year reserve capacity because hey, I'm happy, I'm loving Dynamo, and I'm not going to go anywhere else. If you're that way, yeah, go for the maximum discount. If you're thinking, well, I'm trying it out and I don't know, then maybe a 1 year might be the way to go. But I would always say if you're going to production with an application, you should be doing it on reserve capacity. It's just save money.
All right, thanks.
Yep.
Question about partitions and load testing. So we have a bunch of tables in our load testing environments, and they either have 0 traffic or they have a couple tens of thousands or 100,000 units that are being used. And so with respect to partitions, I'm wondering if you recommend blowing away those tables between tests.
That's fine.
Or
yeah, I'd blow them away. Yeah, it doesn't matter. It depends on your. I mean, it can take a while to create large tables, right? So you might want to keep them around because they've been created, but you can deprovision them, right? So like when I'm not running my tests, let's provision these things down to like 10 RCUs or whatever so that I don't have to worry about it. Maybe they can have 1,000 partitions, but whatever, right? And then when you run your tests, spin them up so they can have the capacity you need, and that way it can happen fast, right? So like if you have like an automated build integration test or something like that, you don't want that thing to be waiting around for 10 or 15 minutes while a table's being created, right? So maybe instead of blowing away the table when it's done, you just dump the data or something like that. Yeah, it's up to you.
Thanks.
Yeah.
Is there a way for us to see the number of partitions on our tables?
I wish there was. Unfortunately, right now, the only way for you to be able to get that information is contact AWS support. They're pretty quick about getting back to you, and we will be providing partition level metrics. There was a big push this year And if you've been following DynamoDB, just been an amazing amount of features that we have released this year, and it's all been things that customers have really been screaming for. Autoscaling, TTL, VPC endpoints, adaptive throughput, snapshot restore. It's crazy the amount of features that have been released, right? Global tables, but partition level metrics have been the biggest request, and I think there was a lot of, hey, let's get the adaptive throughput out there because it's going to lessen the heat, right, for partition level metrics. And now, though, we're going to be, that's obviously starting to rise up the list. So I would expect to see that information. In the form it's going to be coming in is probably in your CloudWatch view. You're going to open up and you say, here's my table metrics, and maybe you drill down and it'll give you the partition level of each one of the table metrics, right? It might give you a total count and things like that.
All right, thank you.
Mm-hmm.
Could you recommend some resources for data modeling best practices for Dynamo?
Yeah, if you can make it to my session tomorrow. Those charts will be available, DAT403. We also have the DynamoDB deep dive from last year. It has a lot of the same information ongoing. Tomorrow is very design pattern focused. My team is actually reworking the docs, the public-facing docs for DynamoDB. It will be refreshed probably sometime Q1 next year, maybe late Q1. I'm trying to get it done, but I'm resource constrained right now. A lot of the public-facing docs were actually written before GSIs were published or available. So the design guidance is not great. So your best bet is to search for the deep dives on DynamoDB, look for those decks, whatnot, and then if you need to, engage the SA team. And we have some really great resources on the specialist team, as well as my team, the black belt team, that you can engage with as well.
Thanks.
Mm-hmm.
I've tried numerous times to do a full table scan on large tables, and never had it look like it would complete with my lifetime.
Yeah.
It doesn't matter what the provisioning is. The metrics page never shows any throttling, but after a few minutes it'll go to like tens of items per second.
Oh, wow.
The latency will be in the hundreds of milliseconds.
Okay. My first question is, what are you table scanning for?
If I need to do a maintenance, I want to visit every record to add a property or something.
Oh, okay. So you're actually modifying the items. Each item you're going to be modifying. So if it's table scan to modify.
Or just read, I mean.
Right. I mean, the reason I asked the question is I have a great design pattern to actually select all the items on a table to meet a particular condition, which is what people most often table scan for. But I don't actually have to do a table scan. I use a GSI to do it. And it's done very efficiently without having to burn a whole bunch of RCUs. But it sounds like if your use case is I actually need to find these items because I'm going to be modifying the schema or I'm going to be modifying some property of the items, and you're doing it to every item, then you need the table scan. And so the condition you're describing is it's just never completing?
Well, when it drops to a few items per second, I have 100 million. Then
yeah, no, that's never going to finish. So we got to figure out why is it dropping so low. I guess my question would be, GSIs? Do you have GSIs on the table?
Yes.
And so you're modifying this data. Are you projecting those modifications to your GSI?
Well, just this morning I tried to do it. I was looking for a few bad records in the table.
Sure.
And I got through about 1% of the table. And
right, before it started slowing down.
Yeah.
This is why I'm asking you,
And there were no modifications at that point.
I get it, but if you see what's happening, I think, I don't know, but I think what may be happening is that when you modify the item, that modification is being projected back to the GSI. The GSI then consumes 1 WCU or whatever the size of the item is. How big are your items?
A few
Small.
K.
Okay, so under a K. So it's going to consume 1 WCU to update the GSI. So if you've increased the throughput on the table to handle this, but you haven't increased the right throughput on the GSI, then what's going to end up happening is sooner or later you're going to fill the buffer between the GSI and the table, and it's going to cause GSI back pressure. So you might be getting throttled at the rate that your GSI can accept the writes. Do you see what I'm saying?
Yeah, so I had a problem this morning where I hadn't performed a single write.
Oh, so you were just reading?
I was just reading. I hadn't found the bad records yet, and it
all right, man. I don't know if I can give you an answer right now, but what you probably want to do is engage AWS support, because that should not be happening. What you're describing is absolutely not a condition that is normal. And it could be that maybe you have a bad partition or something on that table, but what you're describing is just not something that should be happening.
Okay, thanks.
I would open a support ticket, absolutely.